It's question number 10. The lengths in the diagram are given to one decimal place. So this is the accuracy we are given with. Giving your answers to two decimal places in part A, find the lower bound of the area of the triangle. We know that area of the triangle is given by the formula half times base times height. So there is a multiplication of the base and the height. So we need to have their lower bound. In the multiplication, we know that the answer of the multiplication would be minimum if we are going to place the lower bound of the base with the lower bound of the height, because we need to have the minimum answer. So the minimum answer would be the product of the lower bounds, product of the minimum values. So that's why. Okay. Let me have the base is 5.3 and the accuracy is one decimal place. So that means 0.1. So according to the standard procedure, I need to divide this by 2 to have 0.05. So the lower bound of the base is 5.35 minus 0.05. So 5.3, sorry, minus 0.05, which is 5.25. And the upper bound of the base is 5.3 plus 0.05, which is 5.35. This is the upper bound, the maximum possible value for the base. And in the same way, the height is 4.6 and its lower bound will be 4.6 minus 0.05, which will give us 4.55 centimeters, and the upper bound of the height will be 4.6 plus 0.05, which is 4.65 centimeters. Okay, now substituting these values here, lower bound of the base and the lower bound of the height. Half times 5.25 times 4.55, which will give us 11.94 centimeters square. So this is the minimum possible area of the triangle, or we can say that the lower bound of the area of the triangle, which is 11.94 centimeters squares. Okay, now part B, find the upper bound of the length AB. We know that this is a right angle triangle, so the length would be given by Pythagoras theorem, 5.3 square plus 4.6 squares whole square root. When we need to have its upper bound, we need to have the upper bounds of both the base and the heights. So for this, upper bound is 5.35. So I will replace this upper bound 5.35 square and then the upper bound of this, which is 4.65. So this will give me the upper bound of the distance between A and B, or the length AB, which is actually 7.09 centimeter. So this is the answer to part B. And then part C, the maximum possible gradient of the line AB. Since we know that gradient is rise over run, which is 4.6 divided by 5.3. Okay. But we need to have its maximum possible value. Maximum value would be there if the numerator is maximum, but the denominator is minimum. So substituting corresponding values, it would be 4.65 in the numerator and 5.25 in the denominator, this minimum value or the lower bound, and this the upper bound or the maximum value for the height, which will give us 0.89. And since this is the gradient, so it has to be a unitless quantity. So that completes the question, but let me explain it, this mechanism through an example. For example, I'm having 20 and I divide it by 2. I get 10. I divide the same number 20 by 5. I get 4. The same number 20 is divided by 10. The answer is 2. So what we are concluding is that if we increase the denominator, the answer would decrease from 10 to 2. So to have the minimum answer, the denominator should be larger, and to have a maximum answer, the denominator should be smaller, like this. So that's what suggests to have the lower bound of the base in the denominator. And same way, to have the maximum answer, the numerator should be having its maximum possible value so that we can have the maximum answer of this fraction. So that completes the explanation to question number 10.